Hello and welcome to a Maths with Harry lesson. In this video, we're going to have a look at length and area. Now, before we do any maths, I want to just dissect what the title means. I've written it down in grey. Length basically means we're looking at the distance between 2 points. The distance between 2 points is a length. It might not have units on it, we might not have units in the question, but we're able to work out the distance or the length between 2 points. And then the area is, we're going to have a look at areas made by a multiple of points, okay? So if we've maybe got 3 points, connect those together, we'd make a triangle. And how can we use those 3 points to work out the area of that triangle, just for example? So I'm going to start by looking at what we looked at in a previous video where we were looking at the gradient, we were actually looking at the equation of a straight line. But this is how we came up with the gradient. So I have a straight line and it's kind of cut off at A and B, okay? We're just looking at the straight line that connects those 2 points together, okay? And I've said A is x1 and y1 and B is x2, y2. Those are the coordinates of A and B. So for the gradient, what we needed to do is we needed to work out the change in y, and to do that, all we do is just subtract the y parts. Then, to work out the change in x, all we do is subtract the x parts. But we have to make sure that both for the change in y and the change in x, we take away, for both of them, A take away B or B take away A. It has to be consistent. We can't do y2 minus y1, but then do x1 minus x2, because for the y part, we're doing B minus A. But then for the x part, we're doing A minus B, which we can't do. So for both parts, we have to do either B minus A or A minus B, just so the signs add up both ways, okay? So that's what we do, and then for the gradient, we just do the change in y divided by the change in x. So y2 minus y1 divided by x2 minus x1, okay? So what if we're not wanting to work out the gradient? What if we're wanting to find the length? In other words, the distance between 2 points. What if we are trying to work out D? If I call this length between A and B, this orange line here, if I call that D, how can we work out the length of D? Well, I'm going to just draw down here a little triangle, and I'm not going to do it like that, I'm going to do it in grey, okay? Here we have a right angle triangle. There is my right angle, let's do that a bit better. There's the right angle, okay? And let's say we have 3 sides. We have side A, we have side B, and we have side C. Hopefully, to work out the length of sides here, Pythagoras is coming into your head. You would have seen it at GCSE. Trigonometry might also come into your head here, but we don't have any information on the angles. All we have is 3 sides, okay? Nothing is known about the angles, so trig's not going to work here. But Pythagoras is. And Pythagoras says, if I square this side, so let's say a squared, and I square, do it in grey, this side, b squared, if I add those together, that is going to give me this side squared. So that's going to be c squared. And that there is Pythagoras. Now hopefully we spell that right. That is Pythagoras, okay? If I have a right angle triangle, the 2 straight sides there, they're all straight sides, I just mean not the slanted side. The 2 smaller straight sides there, so in this case A and B, square them and add them together will give me the slanted side squared. So we can say from that, that implies C must be equal to the positive square root, because we're not going to have a negative length, the positive square root of A squared plus B squared. So nothing new in terms of maths there, just a little recap from GCSE, okay? So this, the square root of A squared plus B squared, these 2 sides squared, added together, then square rooted, will give me C. So we can answer the question here now that says, well, what's the distance between point A and point B? What's the length of this line D? We'll write it in blue. D is going to be the square root of these two sides, I'll do it in red. This side, in fact, no, what? I'll do it in blue. That's better. I'll do it in blue. That side and that side squared, added together and square rooted, just like we had A and B here. Okay, so it's going to be y, in fact, we'll do the x first. x2 minus x1 squared plus y2 minus y1 squared. Okay, then square rooted. That is what D is going to be. In other words, the distance between those 2 points using Pythagoras. Okay, so we can kind of actually box that off like that, because that's not very neat. That is the formula that we are going to use. Let me neaten that up a little bit. Perfect. Okay, that's the formula we're going to use. Now, you don't really have to think about it in terms of y2 minus y1. You can just think, take away the y's and take away the x's the same way, square those values, add them together, square root. You'll get the distance between the 2 points. So let's have a look at a numerical example. Example 1 says find the distance between these 2 points, the point 2, 3 and the point 5, 7. So use the formula, or just think about it in terms of taking the y's and taking the x's and substituting into the formula. Have a go and then press pause and press play when you're ready to work through the answer. Okay, hopefully we've got an answer. Let's see. The first thing we're going to do is find the change in y. So if I do want to think about it in terms of x1, x2, I'm going to label that one x1, x1, y1 I should have said, and x2, y2, that's better. And then I'll take away this coordinate here from this coordinate. So I'm going to do y2 minus y1. In other words, I'll write it in grey here, the change in y. And the change in y we can see is going to be 7 minus 3, which we can see is going to be 4. Okay, and then I'll do again, we will do the change in x. So to work out the change in x, we'll do x2 minus x1. Okay, and when we do that, we're going to have 5 minus 2, because we're doing x2 first, we were doing y2 first, so we need to do x2 first. 5 minus 2, which is going to be 3. Okay, so we could graph this to actually see what was going on, but I think at A-level it's quite easy just to see what 2 points look like or to visualise them in your head, but do graph them if you want to. And then all we need to do is do Pythagoras on that. So we'll substitute it into the D formula. So I'll actually write it here, the distance between, and I'll call this one point A and that one point B. A and B is going to be the square root of the change in x, which is 3, square that, and add the change in y, which is 4, and square that. Okay, that's going to be then the square root of 9 plus 16, which is the square root of 25, which is 5. So that is our answer. Now, you didn't actually have to go through all of this, because if you've done any Pythagoras work quite at a high level, maybe at GCSE, you might have been able to recognise that the other side is going to be 5. Because if we look, we have 3 as one of the sides, we have 4 as the other side, and we then have 5 as the slanted side. In other words, we have a triangle that is a right angle like that. There's our right angle. This is 3, this is 4, this side is then 5. So they kind of go up in one. It's really quite nice. We've got 3, we've got 4, and then we've got 5. And that's called a Pythagorean triple. I always get confused how to say it. But any other multiple of that is also a Pythagorean triple, okay? So it's quite nice if you've got a side of a 3 and a side of 4, the other side of the right angle triangle will always be 5. Okay, so we didn't really have to go through this working out here. But if you didn't recognise that, it's absolutely fine to do Pythagoras here. So the distance between the 2 points is, we'll just get rid of that grey, it is 5. Okay, so hopefully that wasn't too difficult. Let's have a look at another example. It says point P lies on the line with equation y equals 4 minus 3x. The point P is a distance root 34 from the origin. Find the 2 possible positions of point P. And I've been nice here, I've given you 2 hints. So start off with point P. We don't know what point P is, it just says a point P. So label point P X and Y. And then calculate the distance between the origin, so 0, 0, and P. And then solve some simultaneous equations. So see if you can have a go at that. Don't worry if you can't, just keep watching the video, but do pause and have a go if you want to, and then we'll press play and we'll work through the answer. Okay, let's see whether you are correct. So how can we start this? Well, we start by looking at the first hint, and it says let P be X and Y. So I'll start that off in my solution. So let P be X and Y, and I'm going to calculate the distance between the origin and P, okay? So the distance between 0, 0 and P is going to be the square root of the change in Y's plus the change in X's, and then square those, okay? So in fact, I'm just going to make this a little bit longer, there we go. And then we'll do the change in X first. So I'm going to take away the origin from P. So I'll have X minus 0 squared plus Y minus 0 squared, okay? I'm not thinking about that in terms of y2 minus y1 and x2 minus x1. I'm just thinking, take away the origin from P, get those 2 values, the x and the y values here, square them, and then square root, okay? So basically Pythagoras. Now I've got take away 0 here, so I don't really need the take away 0, so that is exactly the same as this, the square roots, maybe don't need it so long actually, the square roots of x squared plus y squared, okay? Quite simple there, we can just take off the zeros. So that is what the distance between the origin and P is. We actually know a numerical value for that though. If you look in the question, it says the point P is a distance root 34 from the origin. So I can then say the square root of x squared plus y squared is equal to the square root of 34. We've got a square root on both sides, so what I can do is I can square both sides to get rid of the square root on both sides of the equals. So that's going to give me, well, I'll do a little bit of cancellation. The square will cancel with the square root, and the square there will cancel with the square root, just to leave me what's under the square root, okay? So we'll have x squared plus y squared is equal to 34, okay? Just move that up there. We could also think as well, if we've got 2 square roots like we did here, equal to each other, then the thing under the square root must be equal. If the 2 square roots are equal, whatever we're square rooting must be equal, okay? So we've got x squared plus y squared is equal to 34. And actually, for a little bit of interest, that is the equation of a circle. We won't get too much into that. I think that actually might be the next chapter that I'm doing. It is. So we'll get onto circles, but because we've got x squared plus y squared is equal to a constant, that's the equation of a circle. Just have that in your head. Okay. So we've done that, we've let P be x, y, we've calculated the distance from P and the origin, and then we need to solve simultaneous equations. So basically, what we've got is a straight line, and we've also got a circle. So what we need to do is, if I do a little bit of a graph, now don't worry if you're not able to graph that circle, you might have done some circle graphing at GCSE, but we've got x and y there, and then it's going to be at the origin, the circle, so it's going to be something like that, and I also have a straight line, minus 3x plus 4. So that's the circle, x squared plus y squared is 34. And I also need minus 3x plus 4. So it's going to be something like, I can't work out what root 34 is. Let me see. Root 34 is 5 and a little bit. So it's going to be something like that, I think. Where that is 4. Don't worry if you're not following this completely. That's the equation of the straight line. So we have this set up, and basically, anywhere along here from the origin to anywhere along the circle is root 34. So from the origin to the circle, all of these lengths are root 34 because these are the radiuses of the circle. And because this is our equation of the circle, the radius is just the square root of the constant here. So any of these are the length root 34, okay, root 34, all the grey dashed lines. So what we want is the intersection point between the circle and the straight line. We want those 2 points there, okay, that point and that point, because we still have from the origin a distance of root 34. We can see the 2 lines I've just drawn on there, and we are also on the straight line at those 2 points. So what we're asked is, what are the 2 possible positions of point P? It's those 2 red points there. So to work out what those positions are, all we need to do is solve the 2 simultaneous equations. This simultaneous equation here, or that equation, with this equation. Let's do it in black. Y is equal to minus 3x plus 4. Okay, that's the equation of the straight line. So I'm going to solve, I'll write it in green, I'm going to solve simultaneously. Okay, and to do that, I'm just going to substitute in. So I'm going to substitute the equation of the straight line into the quadratic. We'll have x squared plus minus 3x plus 4. And we're going to have that squared is equal to 34. And then we will have x squared plus, and I'm going to try and do this in my head, 9x squared, 8, 16 minus 24x plus 16 is equal to 34, I think. Let me double check that. That's 9x squared. That's going to be 8 minus 24x plus 16. And then if we have the x squared together, that will be 10x squared minus 24x, and take off the 10 and take off another one, minus 18, I think. Hopefully that's right. I have a calculator right next to me, so we could just do a little bit of cheating. Perfect. Okay, then what we need to do is we need to solve that quadratic. Now, I am going to cheat here. I'm going to put that into my calculator, and it's going to give me the answer. You could factorise it or try and factorise to see if it does factorise, but I can see if I do a little bit of working there, I get x to be equal to 3, or I get x to be equal to minus 3 over 5. And I think that does actually factorise, but your calculator will help you. So those are my 2 values of x, okay? I have x being equal to 3 or x being equal to minus 3 over 5. And I can see that that does actually kind of work with my diagram, okay? If I just get rid of these lines here, we'll just use those grey lines to the red points, I can see going down in orange here, that is one x value there, and then going up is another x value there. And it kind of makes sense for that x value to be minus 3/5 because it's negative and it's just a little bit past the origin, and here that one to be 3 because it's positive and it's quite a bit past the origin, but it's not past the circle, and the circle has radius root 34, which is just a little bit over 5, okay? So those are my 2 x values, and then all I need to do is substitute into, sub both x's, so 3 and minus 3/5, into the straight line, We could also substitute them into the circle, but the straight line is much easier because it's linear. So we'll just have 3x plus, minus 3x plus 4. So if I put x is equal to 3, that's going to give me a y value of, we're going to have minus 9 plus 4. Is that minus 5? I think it is. Minus 9 plus 4, of course it is, it's minus 5. So that is 1 point. We could have p at 3 minus 5, okay? Or we could have, and we'll just highlight that, or we could have x to be at minus 3/5, and that would give me a y value of, let's put that in the calculator, minus 3 over 5 plus 4. That's going to give me 29 over 5. Let's just check I did that other one right as well. Minus 3 times 3 plus 4 minus 5, perfect. So then the second position of p could be minus 3 over 5 and 29 over 5. And those are the two positions of p. So the reason those are the two positions is because we worked out the algebraic expression for the distance between 2 points. Then we got an equation of a circle. We can say p can be anywhere along this circle because it works for it to be the distance root 34 from the origin. And then we said, but we want it to still be on this straight line, so we need to solve them simultaneously to work out the intersection points. That gives me two values, so p is either this or the other one. So it's either 3 minus 5 or minus 3 over 5, 29 over 5. Okay, let's have a look at the final example for this video. It says the straight lines L1 and L2 have these equations. They have 4x minus y equals 0 and 2x plus 3y minus 21 equals 0 respectively. Respectively means they kind of match up, okay? We've got L1 and L2 have these equations, so L1 is the first one because that comes first, and L2 is the second one because that comes second. And it says they intersect at point A. Okay, so they have to cross somewhere, and the place that they cross is point A. We want to work out the area of triangle AOB, where B is the point where L2 meets the x-axis. Whenever you see in a question like this, O, so here we've got AOB, O is always the origin. So we know what point A is, that's the intersection point. B is where the L2 meets the x-axis, and O is the origin at 0, 0. So pause and have a go if you want to, and then, like always, we'll work through the answer. Okay, let's see if you've got the correct answer. So the first thing I'm going to do is I'm going to ignore that we've been asked to work out the area of the triangle. We'll get onto that at the end of the question. To be able to get onto that, I'm going to need the coordinates of A and B. And the more questions you do like this, the more you'll realise we need coordinates to help us. So, we know point A is the intersection of these two lines, this line here and that line. So what I'm going to do is I'm going to solve those two simultaneously. And first thing I'm going to do is I'm going to work out point A, which I wrote here, okay? So 4x minus y equals 0 from L1, I'm going to add y to both sides to get y is equal to 4x, okay? I'm then going to substitute. So I'm going to have from L2, 2x plus 3y, which is now 4x, so I'll substitute that into there, minus 21 is equal to 0. Okay, then if we expand the bracket, 2x plus 12x minus 21 is equal to 0, just making sure this is correct, which it is, and then we've got 14x equals 21. I've collected the x's and I've added 21 to both sides in one step there. Okay, so I'll write this actually. We've collected x terms and we've added 21 to both sides to get rid of the minus 21. And then all I need to do is I need to divide by 14 to give me x is equal to 21 over 14, and both of those numbers are divisible by 7, so we can have 3 over 2. So x is 3 over 2, the intersection point. Then all we need to do is work out the y point, or the y coordinate at the point A. To do that, I'm going to substitute that value of x, 3 over 2, into y is equal to 4x. And the reason I'm going to do that is because we're solving this simultaneously with this equation, or without substituting, it's this equation. So we can just substitute x into there to work out the y value at A, okay, because this is the x value at A. So doing that, we'll have y is equal to 4 times x, which is 3 over 2. That's 2 times 3, which is 6. So that tells me the point A is 3 over 2, 6. Okay, just checking that's correct. It is. So that's the point A. Then let's work out the point B. So I'll write that in grey here. Work out the coordinates of point B. Now we're told point B is where L2 meets the x-axis. So L2 meets the x-axis. And I'm just going to duplicate this down here. This is the equation of L2. So here, and B is where L2 meets the x-axis. Now, at the x-axis, y is 0, because anywhere along the x-axis, y is 0. So all I need to do is substitute y equals 0 into there. So let's do that. Sub y equals 0 into that equation, because that's the equation for L2. So when we do that, we'll have 2x plus 3 times y is 0, minus 21 is equal to 0. 3 times 0 is 0, that disappears. 2x, is equal to 21. So therefore x is equal to 21 over 2. Okay? So that is the x value of B, and the y value of B is 0. So that tells me B is at the point 21 over 2, and y is 0. Okay, so we're going to take, I'll do it in green, this point A, this point B, and I'm going to write those as decimals just to help me out a little bit. So A is 1.56 and B is, what would that be, 10.50, okay? And then we know that O, like I said, is the origin. That's always the case in these questions. I am now going to graph the 3 points. So graph the points A, the origin, and B. And that will really help me visualise the area that I'm working with. So here is my x-axis, there's the y-axis, and, well, the origin is there, 0, 0, okay? B is at 10.50, so let's say that's somewhere about there, that's B, and I'll write it as a fraction now, 21 over 2, 0, and A is at 1.56, so A, 1.5 is about there, and 6 is about there. Okay, so 1.5 is 3 over 2, and that's 6. And let's connect all of these points together like that. Okay, so this is now a triangle. I can't really say whether it's a right-angled triangle or not, because I don't know that information, okay? I don't know that, and the reason I don't know that is because this looks a little bit like a right angle, but do we really know whether that's a perfect right angle? From my graph, we might be able to say it looks like it, but we don't know. So it's just a triangle, and to work out the area of a triangle, it's a half times the base times the perpendicular height. So that's all we need to do, okay? Depending on how you look at the base, depends on what you use as the base, but I'm going to use the base as the floor, the bit that looks like the floor, the base on how I'm looking at it, okay? I'm going to use this bit to be the base. So we need to work out the distance between those 2 points. I think that's quite easy. We're from the origin, we're still on the same level in terms of vertical wise as the origin. We've just gone 21.5 to the right, so in the positive x direction. So we can see this has a length of 21.5 from the origin to point B. Okay, we then need the perpendicular height, and the perpendicular height is from the tallest bit of the triangle right down to the base, and those lines have to intersect at a right angle. Okay, the perpendicular height, perpendicular means the two lines meet at a right angle. What is this height here? So we somehow need to work that out. That's a little bit trickier, I think. Or is it? Well, actually, no, it's not. We can just take off the y value of the point A. Okay, all we have to do is think what's y, or what vertical function, if you like, or what vertical way have we travelled. Okay, and we can see we've gone from the origin. We're still at y equals 0 here on the x-axis. We've gone from the x-axis all the way up to point A, and point A has a y value of 6. So we can see this length here must be, and I'll write it this time in green, this must be 6. Okay, and if you want to think about that a little bit deeper, then pause the video, but it's quite simple. And then all we need to do is substitute into the area formula for a circle, because going back to the question, now we've done all of that, what we wanted to do was work out the area of triangle AOB. So we need to work out the area of this triangle. So now let's do that. The area is equal to 1/2 times the base times, and I'll just write P height. That's the perpendicular height. We've got all of those three things. The first thing is 1/2, that's given to us. The base is 21/2, and the perpendicular height is 6. And then taking that from the book, that gives me 63/2. Okay, we don't have any units here because we don't have any units on the graph. Okay, if we maybe said one step to the right is a centimetre, then this would be 21/2 centimetres. This here would be 6 centimetres. So then we'd have our area in centimetres squared. But we don't have that, so that is our final answer.